Here's our flipped lesson on tree diagrams. So what is a tree diagram? It's just kind of a nifty new visualization technique for all the different probabilities. And it really just displays the sample space along with all the possible probabilities. So we're going to do a simple one first by looking at our oh so familiar table with two categorical variables. So one categorical variable was our grade level, the other was whether or not someone voted for uniforms. Okay, so we're going to start with our sample space. Students in the study. Okay, and we have two categorical variables here. One is grade level and one is how they voted for uniforms. I'm going to actually start with grade level because that makes sense to me. So someone is either a junior or they are a senior in this particular study. And then we have our second categorical variable, which was how they voted. So there was either a voted yes or a voted no. And the same is true among the seniors. Voted yes and voted no. So these are my branches of my tree diagram here, but it doesn't have my probabilities on it. So let me go ahead and include my probabilities. So looking back at the table, there were 156 juniors out of a total of 315 students in this study, giving us a probability of someone being a junior at 0.495. Now, normally I would just write the probability and not show you the work, but this is the first time we're doing a tree diagram, so you get both. For the senior, looking back at the table, I have 159 seniors out of 315 students total, so that proportion is 0.505. So great, I have the proportions of juniors or seniors. So now let's look at that second branch. If I'm looking at this voted yes here at the top from the junior branch, that means that these are people who voted yes given that they were a junior. That's right, it's a conditional probability. So this right here is really the probability of yes given that someone was a junior. Okay, and this one that I'm looking at here is really the probability that someone voted no, given that they were a junior. Over here, I'm looking at what is the probability that someone voted yes, given that they were a senior. Here, I'm looking at what's the probability that someone voted no, given that they were a senior. So it's always given the first branch. So for yes given a junior, I would look at this and be like, well, there's 62 juniors who said yes out of a total of 156 juniors. So that's 0.397. For the no's, there were 94 that said no out of 156. So that's a total of 0.602. Now it's lost a little bit, but notice if I add this plus this, I should get 100. That's going to be important later on. Okay, now looking at the yes and the seniors, I have a total of 57 seniors out of 159, which gives me a proportion of 0.358. And then seniors who voted no was 102 over 159, giving me a proportion of 0.641. Again, these two totaling 100. So now I have my different probabilities, right? I have the juniors, I have the seniors, I have my conditional probabilities of yes given junior. So the question is, how would I know about what about the probability of a junior and yes? How would I find that one? So in order to find junior and yes, I would look at this. Well, I know that the probability that they're a junior is this. Junior yes given that they're a junior is this. So all I have to do to find junior and yes is go 156 divided by 315, which is my first probability, times 62 divided by 156. And oh, look, it cancels out. And when I do that, I end up with 0, I'll put it over here, 0.196. So in order to get the and, I multiply this branch times this branch. Okay, if I wanted the and for the juniors and no, I would multiply this branch by this branch. If I wanted the and for the seniors and yes, it would be these two, right? Seniors and no would be this and this. So here's looking at it another way, but with notation. So I showed you how we do it on the tree, but this is essentially what we do with notation. So to find the probability of junior and yes, I multiply that times the probability of being a junior, okay? Well, that is 156 over 315 based on our chart. And we're going to multiply that by the probability of voting yes given a junior, which is 62 over 156. Canceling that out. Oh, look, it's the exact same thing. Oh, hey, 0.196. Now that we know how to do this with both the tree and the notation, this brings us to the general multiplication rule. So the general multiplication rule states that the probability of A and B is the probability of A times the probability of B given A. Now in your formula sheet, you see this written a little bit differently. It looks like this. The probability of B given A equals the probability of A and B over the probability of A. So it's just algebra, but you got this. So we use this formula when we need to find out the probability of A and B. And to figure out the probability of two events occurring together, we just basically take the probability that the first occurs times the probability that the second occurs, given that the first already happened. This makes a lot of sense. What doesn't make sense is when you're looking at the story problems and you're trying to figure out what they're talking about. So let's say they tell you you have a probability of 0.24. It's going to be your job to figure out, well, is this the probability of A? Or is this the probability of B? Or could this be the probability of B given that A has already happened? And for that, we need to read thoroughly. So let's try with an example. So media usage and good grades. In January of 2010, the Kaiser Family Foundation released a study about the influences of media in the lives of young people aged 8 to 18. In the study, 17% of youth were classified as light media users. Pause. This is where I stop reading and I pause and I go, okay, I'm sorry, what? Okay, I need to write that down. So I say, okay, the probability of being a light media user equals 0.17. Great. Then I'm going to keep reading. 62% were classified as moderate. Okay, probability of moderate usage is 0.62. All right, so then I go on to, and 21% were classified as heavy media users. So heavy equals 0.21. Fabulous. So then it says, of the light users who responded, 0.74 described their grades as good, A's and B's, while 68 of the moderate users and 52 of the heavy users described their grades as good. So I'm going to back up and be like, what? So of the light users, so given light users. Okay, so what I'm saying is they've told me that the probability that someone gets good grades, given that they're light users, is 0.74, because it said of the light users. Then it says, well, 68% of the moderate users describe their grades as good. So of the would be given. So I have good given mod is 0.68, and I have the probability of good given heavy is 0.52. So notice I stopped at every point and I wrote down something in notation of some sort. Then I'm saying, okay, according to the study, what percent of people age 8 to 18 describe their grades as good? So I like to start with, what was I trying to find? So what percentage of people say they get good grades? So I want the probability of good. So that's what I'm looking for. So now I'm going to list, what do I know? Well, I know a lot of things, and we already wrote them down, but I'm just going to reiterate them here. Probability of light, moderate, heavy, good grades given light, good grades given moderate, good grades given heavy. When I see a problem with this many probabilities, I don't freak out. I breathe and think, you know what? This is a tree diagram problem. So let's make a tree. Okay, let's start with our sample space. So we have students, and I have a couple of categorical variables, right? Like how well they're doing in school, and then I also have their media usage. But because I was given a probability of just media usage, that is what I'm going to use. That's the trick to figuring out what should start your tree diagram. So I'm going to start my tree diagram by saying light users, moderate users, and heavy media users. And the light I was told was 0.17. The moderate was 0.62, again from the story problem, and the heavy users were 0.12. Then with each one, I have the perception of grades, right? This is what they thought their grades were, right? So I'm going to say good. You know what I'm going to say? Not good. I'm going to say good, not good. Good, not good. Because, you know, I don't want to say bad. I want to say not good. That sounds better, right? Okay, so looking at this, they gave me the good ones, right? So they told me that this was 0.74, given that someone was a light user. They told me that this one was 0.68, and they told me that this one was 0.52. Now I can't actually fill out the rest of the tree diagram. Remember when I said, hey, these should always equal 100? Well, they can. So 1 minus 0.74 is going to be 0.26. 1 minus 0.68 is going to be 0.32. 1 minus 0.52 is going to be 0.48. So I actually have all of the probabilities here on my probability chart, which is excellent, or my tree diagram. So what I have here is the probability of good, write that a little bit better, the probability of good, one more time, good given light, light users, right? But I just want to know what's the probability that someone has good grades. So I need to know all the ones that are good. So that's here, here, and here. So I need to know the probability of someone who is light and good, and the probability of someone who is moderate and thinks they have good grades. And I need the probability of someone who is a heavy user and thinks they have good grades. So in order to do this, I'm going to have to multiply this plus this, right? So I'm going to have to go, okay, 0.7 times 0.74, right? And I'm going to have to multiply 0.68, right? Because that's the good here, times 0.62 using the multiplication rule. And I'm going to have to multiply 0.52 times 0.21. So here are my totals for each of those. So I have each of the totals here. So I have 0.1258, 0.4216, 0.1092. Great. That's 3 different goods. I need the total. Oh, well, let's just add them up. Okay, so I made some more space over here. So basically, I'm going to take the probability of light and good, again, one more time, plus the probability of moderate and good, plus the probability of heavy and good. And I'm going to add all of these up. So this was 0.1258. this was 0.4216, and this was 0.1092, which equals a total of 0.6566. So great. Now I just need to put that into context. So in context, I would say about 65.7% of the students in the study described their grades as good. And there you have it. This is how you do tree diagrams, how we come up with an answer in context. And then tomorrow we're going to be ready to do problems in class. Have a great day.